Mars looks red from millions of miles away, but the reason isn't what we first assumed.
For centuries, people simply called it the Red Planet. War, fire, danger, plague, all tied to that color. But science tells a quieter story. A story written over billions of years. At first, the explanation sounded simple. Mars is red because it's dusty. That idea isn't wrong, just incomplete. Because dust alone doesn't explain everything. To understand Mars, we start with iron.
Mars's surface rocks are rich in iron.
Iron reacts with oxygen to form rust. On Earth, we see this as corrosion.
On Mars, it happened planet-wide.
That rust gives Mars its color. Rust needs oxygen. And oxygen usually means water. That's where the mystery deepens. Today's Mars is dry and cold.
So where did the oxygen come from?
Billions of years ago, Mars was different. Liquid water flowed across its surface. Lakes collected minerals for long periods. Water enabled powerful chemical reactions, including widespread oxidation. This process wasn't brief.
It continued for a very long time.
Even as Mars began drying out. Oxidized minerals remained behind. History locked into stone.
Then Mars started losing its atmosphere.
Solar wind stripped gases away. Water evaporated, froze, or escaped. The surface became dry and exposed. But the rust stayed. Over time, impacts shattered surface rocks. Temperature swings fractured them further. Wind ground them into fine dust.
Dust rich in iron oxide.
Spread across the entire planet. That dust never settled permanently.
It lifted, fell, and lifted again.
For billions of years, creating a global red coating. A chemical fingerprint of the past. Not all reds on Mars are identical. Some regions appear darker.
Others lean brown or yellow.
Each shade reflects a different history. Different environments, different chemistry.
Some minerals form only with water.
Others form in dry conditions.
Together, they form Mars's palette. A planetary mosaic.
Painted slowly by chemistry.
Rovers found hematite on Mars.
A mineral often linked to water. Small round formations confirmed it.
Clear evidence of wet conditions. Past water environments reconstructed.
Hidden inside red dust.
This changed how we see Mars's color.
Red no longer meant lifeless.
It meant altered by water.
And by oxygen-rich chemistry. Long before Mars dried out.
Without water, Mars wouldn't look this way.
Oxidation would be limited.
The planet might appear darker.
Or closer to the moon. Color reveals history. Mars' redness is a memory.
A record of lost water.
Of chemical reactions completed long ago.
Preserved by cold and dryness.
Locked into dust.
Even today, Mars is still dusty.
Storms can cover the entire planet.
Redistributing red minerals.
Slowly refreshing the surface.
Chemistry still in motion. From space, Mars looks uniform.
Up close, it's complex.
Every grain tells part of the story.
Every color variation matters.
Science reads color carefully.
Earth's colors change with life. Mars colors changed with chemistry. Biology never took over. Chemistry tells the whole story.
Patience is the key. The world unfolds in its own time. We just need to watch and listen.
Mars didn't turn red overnight.
It aged into that color.
Through loss, reaction, and erosion.
Each step irreversible.
Each step recorded.
When we see Mars, we see time. Billions of years compressed in the color.
Only minerals. This is why Mars surprises us.
The simplest answer was incomplete. The real one is deeper.
Involving water, air, and time.
On a planetary scale. Mars's red color is not a warning.
It's evidence. Of what once existed. And what was lost.
Permanently.
If humans touch Martian soil,
they'll hold chemical history. Not just dust.
but oxidized memory. From another world.
Mars teaches us to read planets carefully.
Color is never random.
It's the outcome of processes.
Across the chasm of immense time, the universe performs its endless act.
Beyond human lifespans.
The red planet isn't angry.
Or violent.
It's transformed.
By chemistry, not conflict.
The quietude of this room allows the thoughts to finally settle. We must consider the implications carefully.
Mars is red because it lived differently.
Because it lost water early.
Because oxidation took over.
And because time never stopped.
Even when Mars did.
That red glow carries meaning.
Not myth.
Not symbolism. Actionalism.
But evidence.
Waiting to be understood.
Mars is red for a reason we didn't expect.
Reason.
A historical reason. A planetary reason.
Written in dust. Every red grain tells a story.
Of water that vanished.
Of air that escaped. Of chemistry that remained.
Long after everything else changed.
Mars didn't choose to be red.
Physics and chemistry chose for it.
Over billions of years.
Under the same sun, we know